is recording. So this is Chapter 2 lecture. Nope, that says Chapter 3. See, I can read Chapter 3 lecture for fall semester 2022. So there's only 35 slides here, so we should be able to buzz through these fairly quickly, and then we'll go in and do some sample stuffs in MATLAB itself. And if you have questions as I'm going along, by all means, pop them up. If you got, let me see, I can get the chat window open here. I have the chat window open, and or you can just pipe up. Don't hurt my feelings if you speak up in the middle and stop me, because I usually don't have anything important to say anyway. Okay, so Chapter 3, built-in MATLAB functions. Things you should be able to do after this chat is access the help feature. That is probably a really good thing to learn. Ooh, and I'll show you something else that you can do when you're tired of doing homework for hours on hours, and you need something to stimulate the brain. I can show you something that's kind of cool. Trigonometric functions. There's a couple of ways to do those for both degrees and radians. Compute use statistical and data analysis functions. That one will cover pretty good, because there's one thing that students have troubles. I don't know whether understanding or just maybe I just didn't teach it well enough before. But we'll cover that one. Generating uniform and Gaussian random number arrays. Complete and use complex numbers. And the computational limits, I don't know what, I guess it's good to know what the computational limits of MATLAB are, but I've never reached them in actual usage, just when I'm doing the lecture. And then special values built into MATLAB. Okay, so Title 1 and what? Okay, I don't know what that one was all about. Introduction. So we use a lot of engineering computations and some complicated functions. So you're using logarithms, trigonometric functions, statistical analysis functions. There needs to be a space in there. Cool. So there's a lot of stuff that's built into MATLAB that helps you do all these things, and 99% of the stuff you'll do, you can do it with the built-in functions. And if it's not, then you can build your own functions, and we'll learn that in Chapter 6, I believe. Assignment 5, Chapter 6, user-defined functions. So that'll be coming up in a few chapters. So using the built-in functions, MATLAB was written in C language. I don't know if any of you have had C language. That's kind of an archaic language. I think I don't know. Last I heard, they were C pound. I learned C when I was taking my collegiate courses. I started with Pascal, went into C, and then a brief introduction into MATLAB during my intro to engineering course. In fact, this will date me. When I downloaded or installed, there was no downloading during this period of my life. When I installed MATLAB on my computer, I think it was on like 15 or 20 floppy disks that I had to interchange every so often. So many of you probably haven't even experienced any of that. So many of some of the language inside of MATLAB is similar to that in the C language, and some of the others. When you get into the inputs and outputs, especially the outputs, there's a fprintf that was reminiscent of the C language. Your for loops, while loops, do while loops, all those are similar throughout a lot of the programming languages. So if you've got some of that background, you should pick up MATLAB fairly easy. So some of the built-in functions that we'll use, are squirt. I always call it squirt. I don't know why. I guess if you put an I in there, it's squirt, but just find the square root, sine, and exp. So this is one that students sometimes, I don't know if they just don't know about it or whatnot, but I've seen some students set E equal to like 2.817, I think it is, and then raise the number up to that to do this rather than use an exp function. So again, that just shows poor teaching on my part. Okay, so a big advantage, it can be either scalars or arrays in MATLAB. So cool. If you send in an array of data into like the square root, each element would be square rooted, and you'll get a reply back, same size array, but it'll be the square root of all the variables. Okay. So each one has three components: the name, an input, and an output. So the name, like here, is name of this function would be sign. The input, also called an argument, goes inside of parentheses. Very important, parentheses, not square brackets, parentheses. And they can be scalar or an array. And some functions have more than one input. And a good way to determine that, numargn, I think that's one we'll come across here. It will tell you how many arguments are required for a given function. And then there's the output. When you execute a function, it will, most of the time, it will return some kind of calculated value or something as an output. And some functions have more than one output. Case in point that we'll cover, I guarantee we will cover tonight, will be the statistical analysis, your max, min, standard deviation, variation. All those can have, I think, at least two inputs, and it's important to know that and learn that, and I'll show you why here in a few minutes. Okay, onward and downward. So functions with multiple inputs. See, I told you could have multiple inputs. So this one here, this is a rem, which it gives you the remainder of a problem. If you divide one by the other, it returns what's left over. So 3 divided by 10 is 9 with one remainder, so the answer is 1. So this would be kind of a good way to find if it's odd or even. A number divided by 2. If the rem is 1, you got an odd number. If it's 0, you got an even number. That's just a basic, simple example. But this one requires 2 inputs. So you can't do that with just one, because would you go away and leave me alone? Sorry. So, and then again, here is you stupid bug. I hate bugs. So this one here, size. If you use the size function, it returned two outputs, 2 values, but I think technically that's still only one output, at least in the way that I define the outputs, because you've assigned it to only one variable, but it's got 2. So this will be the size, number of rows, number of columns. So there's 1, 2, 3, 3 columns, 1, 2, 3. So 2 rows, 3 columns. See, look at that. Okay, so here we go, 2 outputs. So this one here, by putting assigning the output from this function to 2 variables, and in this case the first one is rows, the second one is columns. When you get into the statistical analysis stuff like max and min, the first variable out will be the maximum value or the minimum value. The second variable will be assigned its location inside of that array. Now this says rows and columns is equal to size. These can be anything you want to call them. I mean, you could call that Fred and George and it'll still work the same, but they'd be kind of meaningless. I mean, you get down here and you want to know how many rows, and you have to stop and think, oh, did I call Rose George or Fred? So, good programming, I don't know, don't want to say etiquette, but just I guess habits would be to use names that describe what the variable actually serves a purpose in life for. So this one here, rows, now you know that there are 2 rows. Okay, got it, right? Any questions, comments, wants, needs, desires, concerns, complaints? Nope, okay, we'll move on. Oh, see, there we go. So as you type function name, okay, so here's some of the neat help that's coming out in the later versions of MATLAB. Is if you, as you're typing in your function, it'll pop up this little window down here and show you exactly what the inputs are and what you're, because some of them have some formatting inputs or some other stuff. And for me, I only have 2 functioning brain cells, and I'm doing good to remember to find the sign of an angle. You type it SIN with a parenthesis. So any help that I can get is, wow, that's cool. Oh, hey, I sliced my finger open. Far out. Okay, concentrate. So yeah, so that is a very helpful thing, and that's why it's called help. See, cool. Let's squirt it. Okay. So there's a couple of ways to get help in MATLAB. If you're in the command window, you can type in help and then the name of the function, and it'll pop up in the command window what help was assigned to that when the function was written. And when we get into user-defined functions, I can show you how to do your own little help features. Or you can do doc, D-O-C, and that'll open up a new window, pop up a window with a document that'll give you even more information than the help does. And it'll show you examples and also allow you links to other things associated with that function or whatever you're seeking help with. And you can use the help feature in the exam. That is totally allowed. Okay, so basic math functions include logarithmics, exponentials, absolute value rounding functions, and functions used in discrete mathematics. Wow, that is just totally tubular, dude. Okay, so some of the common examples are absolute value is ABS. Square root, nth root takes the nth root of a value. You put it in x, this value, this x up here is the number you're trying to find, and this would be, so if you want to find a cube root of 92, you put 92 here and a 3 there. Sign returns whether it's positive or negative. Rem gives you the remainder, exp. Now here's one, log is not log base 10. This is natural log. It's like taking ln of x, but it just boggles the mind why they do that, but they did it anyway. So if you want to find the log base 10, you have to use log 10. Rounds to the nearest integer, round to n, rounds to a specified decimal digit. Fix truncates the nearest toward 0. Floor rounds to the bottom. Ceiling rounds to the next higher. These are all in your textbook and in the PowerPoint presentation. And then here's some more. Factor finds the prime factors of x. Greatest common denominator, least common denominator. Rations. Rats displays it as a fraction. Factorial. Some of our, when we get into loops and whatnot, you'll use a factorial in there. And choose k. This gets into some statistics. Want to know the probability or possible combinations. And at primes tells you all the prime numbers less than x. So if you put 100 in here, it'll give you all the prime numbers between 1 and 100. And then if you want to see if a number is prime, you can just use the is prime. Cool, right? And then trigonometric functions. Okay, so here's some things to remember in trig functions. You can use a degree to rad, which converts degrees into radians, and vice versa. But they're they're not show. Okay, well, are they in the next one? Oh, they didn't show them here. So sine x it shows when it gives you the sign of x in radians, but she didn't show that one. Back. Oh, back right here. But if you do a sine d, we'll do it in degrees. So without the d is radians, with the d is, oh, here it is right here, d right there. And it works with tangent d, cosine d. So it'll give it to you in, if your angle input is in degrees and you don't want to convert it. So here's max and min. So here, like I said, if you assign the output of x, the first variable is assigned the maximum value in that. And if this is a row or a column vector, it gives you the maximum value and its location. If this is an array, say like this one here, it'll return a vector with the maximum for each column, and B would be the location in each column where the maximum is found. Right here, see. So play with that, check it out. It works the same with min. Oh, see here. Oh, I guess it's on the next chart. I've never done this before. It creates an array the same size as x and y. Both x and y must have the same number of rows. Each element in the resulting array contains the maximum value of corresponding position. Oh, wow, cool. So if you add max of x and y, it'll take the maximum from each one and put it down here. That's cool. I don't know where I'd ever use it, but that's cool. I can do it at a party someday. Hey, guys, look what I can do. Okay. So mean is just the average. Median is, I think it's the one that's in the middle, and mode is the one that occurs most often. Sum adds everything up. Prod multiplies them all together. Cross cumulative sum adds them together as it's adding. Gives you a running total. Sort generally sorts in an ascending order. If you want it to descend, put descend in double quotation marks. Sort rows allows you to sort by specified row. And okay, size returns the size of the and height, width, length. Num L tells you the number of elements in your array. So I guess height is how many rows, width is how many columns, length gives you both. No, it gives you the largest dimension. So standard. Okay, so here we get into statistical stuff, the variance and standard deviation. So here's test scores. There's the distributed test scores. Nice little charts. Cool, huh? Right? Yeah. So standard deviation is STDX. Variation is VARX. So there is one problem that comes up that students have problems with. It wants you to find the standard deviation for an array, I think the multi-row array, and also the standard deviation for the entire matrix or array. And so what they'll do is they'll do this. So if you do the standard deviation on an array, multi-dimensional array, it returns a vector of the standard deviation for each column. And then when they try to do for the entire array, they take the standard deviation of the standard deviation. It's not the same thing. So in order to get the standard deviation of this, you need to create it into a column vector. How do you do that? I'll show you. Okay, random numbers. Random, it always boggles my mind that you got to do something to create a random number, but they say that if you just pick a number, it's not random. So there are two different types of random number generators in MATLAB. There's uniform random numbers and a Gaussian. difference between the two is rand. I can't. Okay, so yeah, rand n is the Gaussian, and rand is just a random number generator. So this one generates an array of random numbers between 0 and 1. If you put in a single digit, it'll return a square array. So if you put a 3 in here, you'll have a 3 by 3 result. Well, 2 by 2. But if you put in 2 inputs, it'll give you that many rows and that many columns. So here, put in 3, 2, you get 3 rows, 2 columns. So the Gaussian is a number with a mean of 0 and 1. So look in the textbook, it'll tell you how to get, well, it's one of the homework assignments, so I'm not going to, well, yeah, it's, hi, I'm the teacher. I'm tired. Okay, complex numbers. Absolute computes the absolute value of a complex number. So angle tells you what is it? Computes the angle from the horizontal in radians. Complex creates it. Real tells you the real part. Image tells you imaginary. It wants to know if it's real. And a complex conjugate will take and make the plus into a minus. Computational limits. How close are we getting here? Where are we at? I don't know. I can't see what slide we're on. I don't know. Okay, we'll keep going. So this, hello. Oh, so this is the real max and the real min. So, oops. So 10 times 3 to 10 times 10 raised to the 308 and minus 308, and then it for integer is a lot smaller. So special values, pi is 3.14159. Now, if I had my daughter down here, she could recite to you the first 100 digits of pi. She found a song on YouTube and she just memorized the whole thing. And I'm like, okay, I don't need more than 3.14. Ooh, I gotta show you my picture of pumpkin I carved one year. Maybe, so I and j are imaginary numbers. I have a habit of using I and j as my index number in loops. Yeah, I guess it's okay, but probably not good programming practice to overwrite functions. INF means you've hit affinity, not a number. Clock, if you want to, it sets clock a variable to the current time. And if you do 2 of them, you can subtract them and find the time between them. Date gives you the kind of date. And ESP, oh, that's EPS, the distance between one and the next larger double precision floating part number. Very useful. Okay, so summary. We learned a whole bunch of stuff. Okay, any questions, comments, wants, needs, desires, concerns, complaints?
No.
Okay, what would you like to see here? Let's see. We'll do this in a live script editor. Okay, so let's let me see here. Where am I? I'm in downloads. Let's change my directory over to online. See if I have any data files in here. We have scores.dat. Okay, so I'm going to load that scores.dat just so that I have some data to play with. So when you're loading a data file, you'll be coming into this here in the next chapter or two. You want to have the data file inside of your current folder. And then if you type in load with a space and then the name of the file and its extension, you notice I'm empty here, and if I run this, boom, I now have a variable called scores, and it is a 6 by 2. So it has 6 rows, 2 columns. And if we want to see it, we can just type in scores. And so there's our scores. So let's find out where the maximum value is in the scores. So let's just start off by say max score is equal to max of scores. So this returned a vector where the maximum value in the first column is 9.923, right there, and the second one is 9.987, right there. But now if we take and assign this to two variables, and I like to use location because that's what that is just the location in the scores metrics where these are found, we'll now get two vectors resulted, and the first one is 2 and 4. But now how do I get MATLAB to tell me, okay, oh, that doesn't work. Dang. Okay, you're gonna make me do this, aren't you? You're the one that started it. Okay, hang on. Okay. Okay, well, let's just, I always run into trouble when I try making my own equations. So we're going to define a vector. Oops, not that one. That one. Let's say t is equal to 0 by 0.5 to 25. That'll give us a few digits, and then x is going to be equal to I don't know, t dot raised to the 3 minus 4 times t dot raised to the 2 plus sine of t. What the? You got an equal sign in there, stupid. I know it. I was just seeing if they were paying attention. Okay. So I don't know what I just created. But it didn't throw up any errors. So now if we come down here and find, not find. You guys haven't learned find yet. Forget that. You didn't see, these are not the letters you were supposed to see. Okay. Max x is equal to max of x. So this will tell us what our maximum value was. 0. That's not a good number to start with. What the freak is this? This is supposed to be a multiply. There we go. Now we got a maximum number here. And let's just look at this, see what it looks like in a plot. Let's t on the x-axis, y-x on the, so we can see if this is even. Hello, where's my plot? I'm the teacher. I said plot. There we go. Okay, that's not a good. That's not good either. Okay, let's just find here then. Oops. Let's just go less than pi and get one circle there. Okay, so now we can find out where our maximum is. So this one here, because of our incrementation, maximum should be 1, but because of the increment between variables, it's not quite there. So, but to get back to what we're looking at here, so the maximum is there, but we want to know at what time that maximum is happening. So if we assign the output here to two variables, and set the other one next to location. So it's 4. Is that a time? That's not the time, because 4 is clear down here. That's nowhere near the max. Oh, that's the element number. Oh, I got it. Okay, so in order to get the time at max equals, we go back to the time vector, which is t, and find out what's in the same location as the maximum value, right? Because if this is the maximum, it's going to have an xy, so this would be the y, this would be the x, and so now we see that time at max is at 1.5, and that is about right. Now if we want to get a little more refined on that and a little smoother plot, we can see that the max is actually at 1.55. Did that make any sense, or did I just totally blow you guys away? And hello? Okay. I know where I'm at. So I do have here in my notes on the random numbers. So if you're using the uniform random numbers, the rand, let's do a clear CLC. So if we want to have a random set of numbers, let's say just 15 digits. Oh no, 15. So to get just 15 digits, you have to put in a 1 and a 5. If I did just 15, it would be a 15 by 15, which is what, 225 digits. So let's say we want to change it from 0 to 1 to say I don't know, let's say 6. So now it'll be from 1 to 6. And if we want to go from 3 to 6, I think we add a 3. And then if we run this, and we can find here, if we do max, P will tell us what our maximum number is, and min P will give us our minimum number. So we're way over 6. Oh, because I got to drop this down by 3. There we go. Now we're within our limits because I took the whole thing up. And if you want to do the same thing with the Gaussian, that would be the rand n. Again, we'll do 1 by 5. So this one is based off of standard deviation and average. So if we want to have a standard deviation of 2 with an average of 5, L and a mean of L. So these are all in the textbook.